NEC Article 250.52 specifically addresses UFER grounds, which are also known as concrete encased electrodes. This section of the National Electrical Code outlines the requirements for using a concrete encased electrode as a grounding electrode. A grounding electrode is a conductor that is buried in the earth and is used to provide a low impedance path to ground for electrical currents. The purpose of a grounding electrode is to protect people and equipment from electrical shock and damage. The concrete encased electrode must be at least 20 feet long. This length ensures adequate contact with the earth to provide a low impedance path for fault current. The electrode must be encased in at least 2 inches of concrete. The concrete protects the electrode from corrosion and damage, and it also helps to ensure good contact with the earth. The electrode must be located within the bottom portion of a concrete foundation or footing that is in direct contact with the earth. This location ensures that the electrode is in good contact with the earth and that it is not subject to damage from frost heave or other environmental factors. The electrode must be made of either a minimum of 1/2 inch diameter electrically conductive reinforcing steel bar or rod, or a minimum of number 4 bare copper conductor. The reinforcing steel bar must be without splices. If reinforcing steel is used, all sections must be bonded together using the methods outlined in NEC 250.8. This bonding creates a continuous and effective grounding electrode system. When a bare copper conductor is used, it should be at least number 4 American wire gauge. The connection to the UFER electrode should be made using approved methods. Listed grounding clamps and connectors are generally used for this purpose to ensure a secure and reliable connection. The concrete must be electrically conductive. This is important for ensuring that the electrode is in good contact with the earth. The concrete mix should not contain any additives that would make it non-conductive. The concrete encased electrode must be installed in accordance with the manufacturer's instructions. This will ensure that the electrode is properly installed and that it will provide adequate grounding protection. The UFER ground is considered a very effective grounding electrode because it provides a large surface area in contact with the earth. This helps to lower the impedance of the grounding system, which is important for protecting people and equipment from electrical shock and damage. There are several benefits to using a UFER ground as a grounding electrode. Firstly, it is very effective at providing a low impedance path to ground. Secondly, it is relatively easy to install. Thirdly, it is relatively inexpensive. Fourthly, it is very durable and long-lasting. However, there are also some disadvantages to using a UFER ground as a grounding electrode. Firstly, it can be difficult to inspect the electrode after it has been installed. Secondly, it can be difficult to repair the electrode if it is damaged. Thirdly, it is not always possible to install a UFER ground in all locations. For example, it may not be possible to install a UFER ground in areas with high groundwater levels or in areas with rocky soil. The requirements for UFER grounds are intended to ensure that these electrodes are properly installed and that they will provide adequate grounding protection. It is important to follow these requirements carefully when installing a UFER ground. Additional requirements apply. For example, it is vital to ensure proper bonding of all metallic components within the building's electrical system to the grounding electrode system. This includes bonding the service equipment, metal water pipes, and other metallic elements that could become energized. Furthermore, the size of the grounding electrode conductor connecting the UFER ground to the service equipment must be sized according to NEC Table 250.66. This table specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Also, the location of the UFER ground should be documented and readily accessible for future inspection and maintenance. This documentation should include the location of the electrode, the type of materials used, and the date of installation. When using a UFER ground, it is important to be aware of the potential for corrosion. Concrete is porous and can allow moisture to penetrate, which can lead to corrosion of the reinforcing steel or copper conductor. To minimize the risk of corrosion, it is important to use high-quality materials and to properly seal the concrete around the electrode. In some cases, it may be necessary to use a supplemental grounding electrode in addition to the UFER ground. This is often required in areas with poor soil conductivity or in areas where the UFER ground is not sufficient to provide adequate grounding protection. A supplemental grounding electrode can be a ground rod, a ground plate, or another type of grounding electrode that is approved by the local electrical inspector. Regular inspection and testing of the grounding system are essential to ensure that it is functioning properly. This includes visually inspecting the UFER ground and the grounding electrode conductor for any signs of damage or corrosion. It also includes testing the impedance of the grounding system to ensure that it is within acceptable limits. If any problems are found, they should be corrected immediately. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is important to consult the NEC and local electrical codes before installing any electrical wiring or equipment, including UFER grounds. These codes provide detailed requirements for grounding, bonding, and other electrical safety practices. Following the NEC and local electrical codes will help ensure that the electrical system is safe and reliable. In summary, NEC Article 250.52 AFE provides specific requirements for UFER grounds, also known as concrete encased electrodes. These requirements cover the size, materials, installation, and connection of the electrode. Following these requirements is essential for ensuring that the UFER ground provides adequate grounding protection. Remember to always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements. Grounding and bonding are critical aspects of electrical safety. Proper installation and maintenance of the grounding system are essential for protecting people and equipment from electrical shock and damage. In addition to the specific requirements for UFER grounds, the NEC also includes general requirements for grounding and bonding. These requirements cover a wide range of topics, including the types of grounding electrodes that are permitted, the size of grounding electrode conductors, and the methods for bonding metal parts. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a continuous electrical path to ground. This includes bonding metal conduits, metal enclosures, metal water pipes, and other metal parts. Bonding helps to prevent voltage differences between metal parts, which can create a shock hazard. The NEC requires that all metal parts of an electrical system be bonded together, regardless of whether they are normally energized or not. This is because even metal parts that are not normally energized can become energized if there is a fault in the electrical system. When a fault occurs, current can flow through the metal parts of the system, creating a shock hazard. Bonding helps to ensure that this current will flow back to the source of the power supply, tripping a circuit breaker or fuse and energizing the circuit. The NEC also includes requirements for equipment grounding. Equipment grounding refers to the practice of connecting the metal enclosures of electrical equipment to the grounding system. This is typically done by connecting a grounding conductor from the equipment enclosure to the grounding electrode conductor. Equipment grounding helps to protect people from electrical shock if there is a fault in the equipment. If a fault occurs, current can flow through the metal enclosure of the equipment, creating a shock hazard. Equipment grounding helps to ensure that this current will flow back to the source of the power supply, tripping a circuit breaker or fuse and energizing the circuit. The NEC also includes requirements for grounding of sensitive electronic equipment. Sensitive electronic equipment, such as computers and other electronic devices, can be damaged by electrical noise and surges. Grounding of sensitive electronic equipment helps to protect it from these problems. The NEC requires that sensitive electronic equipment be grounded to a dedicated grounding electrode system. This grounding electrode system should be separate from the grounding electrode system for the building's electrical system. This helps to isolate the sensitive electronic equipment from electrical noise and surges. The NEC also includes requirements for grounding of swimming pools and spas. Swimming pools and spas are particularly vulnerable to electrical shock hazards. The NEC includes specific requirements for grounding and bonding of swimming pools and spas to help protect people from these hazards. These requirements cover a wide range of topics, including the types of grounding electrodes that are permitted, the size of grounding electrode conductors, and the methods for bonding metal parts. The NEC also includes requirements for grounding of agricultural buildings. Agricultural buildings, such as barns and poultry houses, can be subject to harsh environmental conditions. The NEC includes specific requirements for grounding and bonding of agricultural buildings to help protect people and animals from electrical shock hazards. These requirements cover a wide range of topics, including the types of grounding electrodes that are permitted, the size of grounding electrode conductors, and the methods for bonding metal parts. Grounding and bonding are complex topics, and it is important to consult the NEC and local electrical codes for detailed requirements. The NEC is updated every 3 years, so it is important to make sure that you are using the latest edition of the code. If you are not familiar with grounding and bonding requirements, it is best to consult with a qualified electrician. A qualified electrician can help you to ensure that your electrical system is properly grounded and bonded and that it meets all applicable codes. Remember that electrical safety is a serious matter, and it is important to take all necessary precautions to protect yourself and others from electrical shock hazards.